Okay, welcome back to our final session before lunch today. Just a reminder that if you want to ask questions of the speaker, we're accepting questions on Twitter, posted at PyData Seattle. If you are watching the live stream, don't go anywhere after this session. We have some great interviews coming up for you. And anyone in the room, if you want to catch those interviews as well, they'll be showing in Cascade up the other end of the hallway. Our next session now is from Dhruv Madeka, who will be presenting on BQplot.
All right. So, hi everyone. To everyone in the room, thank you for enjoying this beautiful day with me inside. So today I'm going to be talking about BQplot, an interactive visualization library that we developed while I was at Bloomberg. And still, most of the contributors are from Bloomberg. If you want to follow this talk, all the notebooks I'm going to be showing are on GitHub, and just on that link, it's you can follow it there. Okay, so what is BQplot? So BQplot is an interactive plotting library for the Jupyter Notebook. It's Apache licensed. It's completely open sourced under Bloomberg. So you can anyone can use it. You can deploy it in your commercial products. The most frequent question I get when I say, "Oh yeah, have you tried out BQplot?" is really another library. I mean, there's like 10 APIs to remember already, and that's a fair point. Hopefully someone will unify them soon. But why should you learn BQplot in the meanwhile? Well, so we built BQplot to leverage the Jupyter Notebook, to leverage the fact that it's in a browser, to leverage how the interactivity can be bidirectional, to leverage the widgets framework that comes with the native Jupyter. So doing very complicated interactive dashboards is extremely simple in BQplot, and hopefully I'm going to convince you about that in this talk. So the cool thing, which we'll see what it means is that in BQplot, every element of a chart is an interactive widget. That means once you generate a chart, you can change it as you want, change any aspect of it, and that's going to change the original rendering. We come with two APIs, which one is kind of a Matplotlib inspired API, and the other one is an object model. And finally, it's built on the native Jupyter Widgets ecosystem, and so it plays well with anything else that's built on that. So if you want to do 3D visualization, that includes Py3.js. If you want to do leaflet visualizations, IPyLeaflet. If you want to do really complicated 3D visualization, I think Martin Brettles wrote IPyVolume. And just so this is the BQplot team. Out of that, I think Jason is sitting right there. Most of the people are at Bloomberg in the quantitative research group, except Jason. And Sylvan is at QuantStack, and I'm at Amazon. And we're always looking for contributors, like any project. So if you like this stuff, feel free to go to the repo and submit a PR. We're happy to review it, and we're usually quite active on the Gitter as well. Okay, so BQplot. Let me see how that looks. Maybe I'll zoom in a little bit. Okay, so let's start the live demo, which is always risky. So forgive me if there are any bugs. So say we have a set of data, say X data and Y data, and we wanted to plot that out. BQplot works exactly. It has an API that's inspired by Matplotlib, so plotting that should be pretty simple. You just do a little scatter plot, and you have it, voila. But the cool thing about BQplot is that what's being rendered is actually a fully interactive web element. So you can zoom, pan, you can do whatever you would like. You can save the image, you can reset the zoom. It's really, this is a web element in the browser that you can live edit. The cool thing about that is once you define this object scatter, you can change any aspect of it after the fact. So if you say, let me change the Y values of the scatter, that's going to change it right within the notebook itself. It's going to change the original plot. BQplot is based on D3.js. The cool thing about that is you can leverage all the different things in D3, including animations and selections. So if you set an animation time of, say, 500, and then you change the plot, so each time you change the plot, you're going to see that the plot is going to animate as pretty much any D3 visualization would. Yeah, so you can change the colors, and it's going to make it red. You can change the marker. It's going to make it diamonds if you want. The thing that makes BQplot really powerful, the reason that you can build fully interactive applications from it, is that if you define, say you define a function foo in Python, you can actually say through the magic of traitlets that for my scatter plot, I want to observe the function foo whenever the y values are changed. Okay? What does that mean? That means that, say we set the enable move property to be true. That means that every time we take a point and we move it, foo is going to be called. So it's truly bidirectional in the sense that yeah. So if you change the function, it's going to it's going to give you let's print what it sends to you. So in that case, you can just, what it's going to send to you is, oops, I messed something up. Never do a live demo. That is really the greatest risk you can take. It's going to send to you the object that it's going to tell you which indices were changed and what the values of the data points that were changed were. So that's not the only API that BQplot comes with. It comes with an object model too, which really respects the kind of grammar of graphics paradigm, which means that when you construct a chart, you construct it from all the different elements like a scale, an axis, a marker, and finally you compose all of that into a figure. So in BQplot comes with these set of objects that are called scales. There are many different types. In this case, we pick a linear scale. We import the object called scatter. We pass the scales to the scatter so that it knows what's going on. We can create two axes, an x-axis and a y-axis, and a figure which contains the marks, which are the scatter, a title, and axes, which we defined above. And once we show that, that's exactly the same figure. So there's two ways to compose the same plot. The good thing about this is that, well, you can do this in the other API as well, but you can say you have a set of color data, say this was a stock price and you'd bought it or sold it at a certain time. You can define color data, which would be a NumPy array in this case, just in zeros and ones for when you bought and sold it. Scales don't only apply to the x and y axis, they can also apply to colors. So you can set the scales to be, you can just add a color scale in this case and set the color to be the color data. That's going to color the entire plot based on the data that you passed it. So you can, basically you can color, or you can use the color as an extra dimension to represent one more aspect of your data. If you use the bars, so if you want to compose many different charts on a single figure, all you have to do is make sure that they share the same scales, and then just add them to the figure. And once you do that, you have pretty much you can do an arbitrarily complicated graph, no problem at all. So if you guys do want to look at the different marks that the markers or the types of plots that we support, the BQplot examples are a great place to go. We have bars, candles, graphs, now grid heat maps, histograms, lines, bars, pretty much everything that you want to do. We also have geoplotting, some of the best that I thought. So let's try that. So if you, in this case, if I have a data file which contains the results from the 2008 elections county-wise, I import a scale which is a geo scale, like say Albers USA, and I just pass into plt.geo this. I just say generate a US counties map for me. You can pass an arbitrary GeoJSON file there, and I pass the color to it. The cool thing is you can define a tooltip. BQplot comes with a tooltip object, so I'm asking it to look at the fields ID, name, and color. So, and you can we're calling them something else. So once you do that, if you display it, you get a full chloroplet, like one of those 538 maps, and if you hover over any one of them, it displays the data that you requested for it. So all of this is on the Python side, no JavaScript necessary. I think we're missing Alaska data. The cool thing is, actually the tooltip doesn't need to be this tooltip object. It can be anything that's basically an IPython widget. So actually, a figure is an IPython widget. So why don't we try that? We're just going to make the tooltip, instead of making it a regular tooltip, we can make it a full-scale. Oops, I didn't set it. Counting that. Not sure what's going on here. I'll have to look into that. A final thing we have is selections. BQplot also incorporates D3's notion of selection, which means that when you select a point, it's going to know that you've selected them. You can select a lot of different points. So the selected is a trait, so that means that you can, so say I have the, it knows which points are being selected on that particular graph. You can observe the selected, so when selected is changed, you can print it out. So selected is also a trait that you can control. So if you selected this or that, it knows which ones are being selected, and that's the data that your function is going to be getting. So how do we use BQplot? So I work as a researcher, so having visualizations is cool, but there's no particular reason to deviate from Matplotlib. One of the big reasons we actually use it is because the interactivity lets us kind of figure out quickly what exactly is happening with our model. So in this case, let's pick the simplest model that everybody knows, linear regression. Let's say that we observe whenever the y is changed, we're going to observe this function, which is going to calibrate the linear regression and change the line. So you see, as you move it, the line is going to recalibrate and change according to the point. So you can actually physically see what happens if your data had been changed a little. It's kind of like a visual derivative. So every time you change a point, basically it recalibrates the regression, so you can see how an outlier might affect it, or you can add points or remove points, and that will work as well. So as I was saying earlier, one of the great things about BQplot is that it's built along with it's built on the IPyWidgets framework. That means that any library that's built on the IPyWidgets framework can be leveraged, including the IPyWidgets. So in this case, we're going to look at something simple. We're just going to build an int slider, which is an object that IPyWidgets provides to control the order of a polynomial. And we're going to say that anytime the value of the slider is changed, you're going to call this function paramsChange, which just refits the polynomial regression on the points that have been generated. So in this case, you have a first order polynomial. You can increase the order. It's going to be a second order polynomial. You can keep increasing it, and the method is going to keep fitting. And you see, gradually you start overfitting the data. That's kind of how we use BQplot. We were a team of researchers that built it, so we really built it with kind of data science and basically research in mind. And the hope is that you can use it to kind of understand your model better, understand your data better, especially now that data is growing rather fast, and hopefully the interactivity can help you with that. So one of our favorite examples is in data visualization is the Wealth of Nations. It basically was a graph done by Hans Rosling, bless him, a while ago, and he was plotting for each country on the x-axis their income per capita and the life expectancy on the y, and using the size of the bubble as a way of determining the population of the country. In BQplot, that's super simple to do because everything is in Python. So we're just going to read the original JSON file. We're going to clean it so that if there are very few points, we don't really want to show that. And we're going to generate, and a lot of countries have missing days, so we're going to linearly interpolate between those dates for both the income, life expectancy and population. So we do that here. So one of the big things that he did was he used he fixed the scale. So the scale being the x-axis representation, he fixed it over the min and the max, so you really saw the behaviors. In this case, we're just going to compute the min and the max for the x, the y, and the population. We'll define a function that's going to get us the data for each year that we want to choose. So the first thing we do is we define a tooltip. We pick the fields. So in the case, since we're going to do a scatter plot, we want the name, the x, and the y. So that's going to be the country name, the income per capita, and the life expectancy. We're going to have a label because the way Mike Bostock did it, I believe, is, or Gapminder did it. Yeah, they put the x and the y. They put a little label for the year in the bottom. So we're going to try to recreate that. After that, we're going to have a log scale on the x-axis since income is actually grown exponentially. A linear scale on the y, an ordinal color scale, which means that we're going to color by category, and we can define the category as the region that they're in. So he colored it by continent, I believe, initially. And we're going to define two axes for those. We're going to get the data for the initial year and create our scatter. So X would be the income per capita, the Y is the life expectancy, the color is the region, the size is just the population. The names are the names of the country. We won't display the names to not clutter the plot. We define X, Y, color, and size as the different scales that we're going to need. And finally, we're going to put a tooltip on the hover. So we're going to set the style. I mean, when we set the unhovered style, which means that the points that are not hovered over, we're going to make their opacity low to create focus on what you're hovering over. We're also going to add one cool thing that I don't think Mike Bostock or I think this one. So this was the original one. I don't think he had a hover. He had the little label and text slider over here. So what we're going to do is we're going to add that. So we're going to add a line. Pick a time interval. We're going to create a slider for the year instead of using a text slider, though that's there in IPyWidgets if that's what you want to do. And every time a different point is hovered over, the scatter has an attribute called hovered point. So you could just observe that. We're going to set the X, the Y, and we're going to set the line to be visible. So now every time the slider is moved, we just set the X, Y, and size of that for all the points to exactly the data for that year. Finally, we add a little play button, and we use the JS link function in IPyWidgets to link the slider and the play button. And voila. So that's going to give you this little application. If you hover, you see the path of any country in income and life expectancy space. If you move the little slider, you're going to see it animate and generate the original, pretty much the original visualization that he had. And at any point, you can hover over the country and see its path. You can also play the entire thing, and that's going to create a little animation for you. So that's a full-blown web application that we've just generated in pure Python code. We didn't write a single line of JavaScript, and we pretty much have all of the interactivity that we might need. Other ways that we use it, me personally, I've used it to create a kind of tensor board for data visualization. Essentially, anytime, since BQplot Live updates a chart, you can always have streaming data. So basically, anytime the stream changes, you can just or the data changes, you can just update your X and your Y, and that's going to trigger a change on the line chart. The cool thing about that is basically that if you're training or testing a neural network, that helps a lot because basically the plot updates as each epoch ends in training, and you get both your train and your test errors that are updating as the neural network is kind of changing. So that's one way we use it to not have to really look at print statements or things like that. You can also have the print statements, but you can basically, here you see how the aux score is changing for your train and test data. So it's going to keep streaming as all the data as each epoch loads. This helps a lot because you can do this with any visualization. Basically, here we're using Keras, and we're using the callback function that Keras provides to just change. We're just doing everything in this function, test underscore call underscore back, and that's just changing the x and the y of the line based on what score we're getting at that point. So that's one way in which we use this quite a bit. The more advanced ways would be to do something like if you had your actual network, you could hover over each one, and you could get the gradients, or you could get the weights for each of the different layers. The cool thing about that is you can study whether, typically networks that generalize better are ones who have more of their weights concentrated typically at the front of the network versus the back. So you could study whether you have better weights at the front and the earlier nodes or in the later nodes, and you can focus on each one of them. This is part of the new GraphMark that Chakri built actually a couple of weeks back. Since like I mentioned, any figure can be put into a tooltip, it's no problem at all to do this. You basically, all the code is here. You can change the epoch and then see what happened to the weights. You can plot the weights as a function of the epoch. You can view the gradients if you want. You can see whether your gradients are dying or what exactly is happening, or whether you want to aggregate it by node or by layer. You can look at that. There's plenty of things that you can do with all of these different marks. The question is, and all of it is in Python, so it doesn't really break your data science workflow to have to do that. The final cool thing that we have is the notion of an interaction. So for BQplot, we've defined a kind of grammar of interactions. By the way, we built this before Vega Lite. Someone mentioned that earlier. There's two ways of interacting with your chart in BQplot. One is an interaction layer. So those would be the kind of classic D3 selections that you see when you put a little pane over the thing, and as you move the rectangle, you see different things happening. So in this case, if you have a line chart, you can have a selected thing on top of that. And if you see here, if you observe the selected attribute, you're going to see what exactly is being returned to you at that point. And again, all of this is on the Python side. All you have to do is create from the interactions. You just need to create, say, a fast interval selector. It's one of our more novel interactions. Basically, if you go up, it increases. If you go down, you can even freeze the size or freeze the thing as you move around. It's a pretty fast way to interact with the data. You can use index selectors. So that's going to return only a single point to you. You can, the cool thing is, so if you look at the selected attribute of the interval selector that you're defining, it's going to return coordinates to you in the scale. But if you look at it on the element on the plot that you're generating, that's actually going to return to you the indexes of the data that you're selecting. So you could imagine that actually you could use this to index a subset of your data and perform a computation on it if you had to. So that's one of the cool things we can do with BQplot. There we have many different types of selections. We have brush selections. You can customize them quite fully. We have two-dimensional brush selections, brush with dates. You can select histograms. If you had to, you could select the bins of a histogram and visualize what's happening there. It's going to tell you exactly what coordinates you're selecting on. You can also have multiple selections on the same graph. If you absolutely had to, it'll let you know what's going on there. Control or command? New to a Mac. Yep. So there you go. So you can have multiple selections on single graph, and it's going to let you know which things are being selected. There's also a lasso selector. So if you, oops, I forgot to declare something. Yeah, there we go. Yeah, you can do multiple selections with dates, lasso selections. We pretty much have everything kind of built in at this point. We also have some pretty original visualizations that we build specifically for financial use cases. In this case, we call it a market map. It's kind of a grid map, which is laid out in a much better way. So here you see you don't really see anything, so you can just change the colors, change the text. You can change the title of the map. The cool thing is this tile map comes with some amount of grouping. So the great thing about grouping is you can group by continent. Let's say, so if you had if your data has natural inbuilt groups, you can show that in your tile map. You can show the groups if you would like. You can select certain cells in this case, just like the scatter plot. You can also change what you see when you're selecting those cells. You can also, the cool thing is you can use it as a kind of a pseudo choropleth. So in this case, we're going to color by the GDP of the country. And here you can see that that's going to generate kind of a mini choropleth where the countries with the highest GDP are the darker colors and the ones that have the lowest GDP are lighter. You can add a widget as a tooltip. So you can have the historical GDP of a country based on whether you hover over it or not. So here, if we hover over Andorra, that's the historical time series for Andorra. For Bulgaria, I mean, it's a pretty fast way to visualize all your data, especially if you have a time series for each of your different data indexes. And it's super easy to do. Basically, you just look at which symbol was hovered over, and you change an aspect of the line, and you change the title of the figure. That's all we're doing right here. We're declaring a market map. We have a tooltip, which is a figure. And basically, there's the market map has a method called onHover, and for that we call this function hover handler. In that we just get which element is being hovered over. We get the data for that element, and we set that to be the Y of the line, and the name of the country to be the title of the figure. So with just that much, you can pretty much have something quite complicated like this. So that's, I mean, those are some of the benefits that we see in terms of using BQplot. We also provide a lot of different mark interactions. If the idea is if what you want is for people to interact with your plots directly, so you can select on a scatter chart. Or you can set the selected on the Python side, say when another plot was changed. You can have tooltips. You can do any widget can be a tooltip. So if you can have a drop down as a tooltip, I don't know why you'd want to do this. It's clearly just a proof of concept, but you can have pretty much anything you would want as a tooltip. You can put a figure as a tooltip. You can do whatever you would like. Basically, it's no problem at all. So in this case, when we hover over a point, when we hover over certain points, this one, yeah, that's going to generate a line chart. Pretty much all of the plots come with the same grammar. Here we can have a line chart that we can look at we can do a certain thing when the legend is clicked or when an element is clicked. So here it's going to tell you this element was clicked, but if we click the legend, it's going to let you know that the legend was clicked. Basically, it's aware of what's happening, and it lets you know on the Python side so that you can declare a function that then does something according to that. We have the same things in the bar charts. You can select different bars. You can have tooltips for those bars. You can have separate behaviors for hover and for click. We have a whole grammar for this interaction specified. You can do the same thing for histograms. You can look at the counts and the midpoints. You can make the tooltip on a click if you want to freeze the tooltip. You can even do it on a legend click if you would like. That's no problem at all. We have pie charts with selections and clicking. Let's say our interactions are pretty robust, and yeah, we've built them out pretty well. So we're pretty happy at them. At this point, what we're looking for is We also have we've built out a set of applications. In this case, we call it DNAs. These are all in the BQplot repo. So this is a way to filter out your outliers. So here we're coloring the data which has the furthest outliers. This is a canvas-based heat map that we have. So you can increase the range in which you filter out. So you see that in this case, all of these points are the negative outliers if you wanted to move the slider on the left. This is the int range slider, float range slider from IPyWidgets. So you can increase the amount that you let out, and in that case, you can visualize all of your outliers and try to see if there's any sort of pattern that's emerging, whether they're on a particular day or they're at a particular time. There's really pretty much anything you can do with these. You can also set it Pythonically if you want. And if once you've cleaned the data visually, you can get this clean data frame in Python. So that's a filtered data frame that you can then use to do your data analysis. So it's kind of a visual way. The cool thing about that is this is an object. So we define it as an object. So all we have to do is pass our data frame to it as so. And once we get this clean data frame, we can then pass that to another object, which is in turn going to generate another one. So we can do multiple filterings depending on which direction we have. So that's another way we use BQplot. We try to define objects that perform some sort of computation on the different data we have, and then become reusable because each instance produces a separate visualization that can then manipulate your data. Yeah, that's kind of that's the start of my talk. I wanted to leave some time for questions, if anyone has any. Hopefully.
Let's thank the speaker first. Where is my microphone gone? As it happens, I don't have any questions come in. So if there are any from the room, then if you'd like to stand up and ask it, I'll repeat it. Yes, please.
How easy to take that and transform it into a dashboard?
How easy is it to transform these plots into a dashboard?
It's actually pretty simple. We're doing that right here. So IPyWidgets comes with a set of V boxes and H boxes. So H box is just a box that aligns them horizontally. V box is vertically, and any widget that you have, whether it's a slider, a play button, or another figure, you can put those. In. You can just arrange them like that. So it's pretty easy to build a dashboard from that. So you just have to put them in boxes and arrange them how you want.
Yeah. And of course, publishing a notebook in a way that it's running somewhere in a controlled fashion and rendering the thing is a completely separate problem from plotting. I know there's a number of people working on that separately from this, but that is something to look at. It's definitely in progress in various ways. Another question back there.
Is it possible to use this to annotate data?
Is it possible to use this to annotate data?
Yes, you can definitely use it. So one of the things that I showed was selections. So you could have a Python function when you select a particular point. So let's say you have your scatter plot and you select a point. You can call a Python function. So if you have a Python function that's annotating your data, so say you would get the index of this point, you could then type it in a text box or something from IPyWidgets. It would be no problem. So it could be a visual way to do that. We've never used it like that, but let's say the simplest thing I would think is you use a selection and use a text box from IPyWidgets and a button. So when you select a point, you type in the annotation and then you hit annotate in the button. So it wouldn't even be too many lines of code actually, it'd be pretty few.
So a question that I've had come in, I think an easy one, where does the name BQplot come from?
So we built this while I was in the quantitative research group at Bloomberg. So it's Bloomberg Quant Plot, BQplot.
Nice and straightforward. And is it possible to export these plots into a venue other than notebooks?
Yes, so there's two levels of exporting. If you just have a static visualization that you want to show, say you have this, say you have a pretty map that you would just like to put inside of a web page, all you have to do is click Notebook and then embed widgets. And what that's going to do is it's going to run a lot of computations in the background. This is the wrong notebook to do it because there's a lot of JavaScript in this. Yeah, let's try it with a simpler one. Let's try it with this. So, The Jupyter.org webpage. Yep, so here we have an embedded plot right there. So you can embed it as a static visualization, or, well, not exactly static, it still has interactions. But as long as you don't have a Python callback, it's extremely simple. Basically, if you hit embed widgets, it's going to generate the JavaScript for you that you can then copy into a web page, no problem. And the issue, if you do have a Python function and it's a full interaction like the Wealth of Nations, that's something that there's active work in progress towards doing.
Excellent. Do we have any more questions in the room? Would everyone just like to see him go through 10 more samples of really cool looking visualizations? I've been enjoying that.
So it's always the flashiest demos, the
they're all the flashiest
visualizations. Yeah, colors are pretty.
Okay. What kind of feedback were you getting from within Bloomberg from the people who ended up using these? I know we all get very excited about developing visualizations and making them look great, but how have they helped people get their work done better or get it done faster?
So someone at Bloomberg might be able to speak better to that, but so from the open source community at least, what we've seen is that, people really, it's a different paradigm to be able to build these kind of complicated visualizations purely in Python. We do get requests to have it be embeddable in different pages or to be, work directly from a Python script. But mostly what I've seen people use it for is that now that they have the computational power of Python with the visualization capabilities of D3, they essentially use it to build kind of sophisticated dashboards that are doing something pretty intense quantitatively, whether it's principal components analysis or it's neural networks or something like that. So they're kind of mixing it with, so the feedback was good from researchers in general.
Great, and I can see just at the bottom of the page there, BQplot is something that we can condo install. So this is open source project now, welcoming contributions.
Yes, that was something we're on. It's really easy to install. If you clone my GitHub repo, there are install instructions there. We're on pip and on Conda, and we're open source on GitHub, Apache licensed under Bloomberg. So we're welcoming all contributions, and the user base is growing kind of fast. So we're happy to see that.
That's excellent. Well, I really love the style of this and how simple it is and how nicely laid out the API is. I feel like that's something that's been missing from a lot of plotting APIs in our wonderful history of visualization. Are there any last questions from the room before we wrap up for now? Yes. Can you do 3D plots?
So the cool thing is, I think that was my computer that went off. Sorry about that. So I think as I mentioned, we're part of the IPython ecosystem. So if you want to combine, I think Martin Brettles has so you could do, I think he has a demo right here. You can do 3D plots, you can move it around, you can do whatever you want. And the cool thing is, if you want to lay them out with BQplot to create, 3D plot with a 2D plot, you can do that easily through IPython, just to put it in the different boxes. So it's the idea is hopefully here to build we also have Three.js, so it'd be pretty much, so the idea is to use the different components of the ecosystem to build a singular thing.
Great. I have one last question that's come in from online. Have you heard comments from the other visualization packages? How do they feel now that BQplot's coming out and saying, hey, we can do really cool stuff?
We've not heard.
Haven't been threatened, attacked?
And they came with NDAs. And they were like, oh, yeah, here's an NDA purely to threaten us. Definitely one of the things that we do see, what would be great in the Python ecosystem is to have one API to all the different types of visualizations, because BQplot does interactivity better, but Matplotlib is really, it's got a vast range of visualizations. It's the workhorse, and hopefully if we can have one API into all the different things, that would be definitely useful for people, I think.
That would be great. Well, let's thank Dhruv again. For those who are here at the conference, we're going to be serving lunch in the main hallway. You've probably got about 10 minutes left to sign up for lightning talks before we start selecting and notifying who will be doing those later on in the day. People watching the live stream, you're about to get some really exciting interviews from a couple of really cool people, so stick around for that and enjoy the rest of your day. Thank you.